Start streaming. Yeah. Cool. All right. Hello. Hi. Thank you for joining me. It's a beautiful Friday afternoon here. I'm looking forward to the end of this stream so that I can take a nice bike ride. But before that, we have some work to do on Breakout for the Game Boy, which we're making. I'll just show you what state it's in right now. So we got a ball, we got a paddle. There's apparently some bugs. Did this? Huh. I don't recall it being broken like this. Yesterday. Huh. I wonder what happened. It was working just fine, I thought. And now it's not. That's annoying. Well, I guess that gives us something to do to start the day off, huh? Wow, I feel like I'm taking crazy pills. It was working just fine. I could have sworn. I could have sworn. So yeah, we're not. It's clearly I did something to mess up the computation of what tiles to delete. Probably this stuff here. So, huh. Well, okay then. That's wrong. I'm pretty sure that's wrong. The row here is that. Is that alone it? That alone might be it, actually. I must have made this change when I was doing the refactoring and forgot to recompile it properly. Yeah, this looks better. There we go. I must have forgotten to recompile it or test it properly or something. Well, that was slightly concerning, but at least we got that fixed. How's that for an introduction, huh? Hey, look at this thing we're working on. Oh, it's surprise, it's broken in a completely unexpected way. I didn't even commit these changes. What was the last one I did? Or compute map offset using stored. Yeah, we'll say that. We compute the row map offset using the stored row in the column. Okay, sorry about that. So as I was saying, we got Breakout going. It's looking pretty good, but it's still not a game yet. So that's what we're going to work on today. We're going to try turning this into a game. And so, like, what is it that a game sort of has to have? Like, I don't know. This is a deep philosophical question if you care to do it. But ooh, it looks like my flaky collision detection finally bit me. The ball went right through that corner. So we'll have to fix that too. But, sorry. Games need to have win conditions and loss conditions. That is to say, well, I mean, roughly speaking. I don't want to speak for all games. SimCity, you can't win, and so on. But, you know, Breakout, you want to be able to win. You want to clear all the bricks out and then have it say you won, or, you know, lose your lives and then have it say game over, you ran out of lives, and start over, and you have to start over again. So we're going to work on implementing that kind of functionality today. I think I've been very sloppy about how the collision detection is handled, and I think I'm starting to see that, you know, for the sake of keeping things simple and for the sake of keeping things efficient on the Game Boy, but I'm starting to see how that's not going to work out in the long run. Because it's just going right through a lot of these things. That might also be another thing. That might also be if on it, yeah. So that was another thought I had. I have it using one single spot to update the VRAM update data. And I went into this in probably exhaustive, annoying detail yesterday when I was implementing this. But right now we can only clear one ball per frame, or one brick per frame. And if, when we're doing the Y collision, we hit a brick, and then when we're doing the X collision detection, we hit another brick, the former will get ignored. So I do think that I'm going to need to have like a series of updates. I think that's what I'm seeing there in places where the ball is just going right through the bricks. I think we've internally updated the bricks in terms of like the actual memory of the stage data, which is what we do right here, but we haven't properly updated the screen. So, geez, a lot of little things to do today. Do we want to spend our time polishing the game and fixing some bugs, or do we want to spend our time adding new functionality? Let's spend our time fixing some bugs. So I'm still going to try to keep my VBlank update routine pretty simple. Actually, I'm going to first move my VBlank stuff off into a separate module. So new file. We're going to grab this. This can stay there, but this can go in a separate file. No, actually, let's put this. Let's put this in a separate file too. I'm very indecisive, which probably isn't the best quality for Twitch streaming, where I'm trying to communicate some sort of sense of authority and knowledge. It is probably, you know, I'd like to think a good quality for a programmer to constantly be questioning their judgment. So I'm going to first move everything into this separate module, just to keep my breakout.asm module as clean as possible. Which it's not right now. It could go for some cleanups, but like there's no reason to have the stage stuff and the background tiles in here. So actually, maybe that's what we should do first: is spend a little bit of time refactoring and cleaning up. Oh, and I need to add it to the make file as well. Let's build. Let's reload the ROM to make sure nothing is broken. Yeah, everything looks good. Okay. So where was I? Git status. Git add make.back. Git add breakout. Git add VBlank. Git canvas. Move VBlank into its own module. So we've done that. I'm going to do some more. I'm going to move the tile data into its own module. So I've got sprites.asm. I'm going to do something similar. I'm going to call it tiles.asm. And we'll just add that to the make file as well. Once again, build, unknown symbol. Oh, and that was actually probably there before too. Because we need to, yeah, okay. That builds, that built. Okay, so that built, I'm going to reload the ROM, and everything's working good. Okay, so two things now. I need to do an add-p. I don't want that change. I don't even want that change. I want that change, and I want to amend that to my previous commit. This should have been there in the first place. And move tile data to its own module. Next, what's next? The stage stuff should go into its own module. Yeah, okay. So, same deal. Stage data goes here. We're going to call it stage.asm. Actually, we're not going to call it stage.asm. We're going to call it, because I want to, well, no, I'll just put it all in here. It can all just go in one place. It's fine. Like so init stage is going to go with the raw map data in the ROM. But the rest of the stage code isn't necessarily, but I might still just keep it all in one ASM file, because eventually it is possible that we're going to run out of the 32 kilobytes of ROM space that the Game Boy can map without the help of a mapper chip. And if that happens, it would be nice if we can just relocate this data to any bank, and then also put this code alongside it in one of those banks. If I completely explain what I'm talking about, it's going to get way outside the scope of this video. But like, it's just, let it be said for now that if you start putting data in separate banks, it's usually helpful to also put the code alongside it, the code that uses it alongside it. So that's why I want to keep the stage data and the init stage code together in a particular bank, but then not necessarily this draw stage code, which doesn't actually use all this raw data that is going to be in ROM. So let's see, and then draw stage goes here. I don't know why, but in the main module, it seems to want to be using larger tabs than it's using elsewhere. VS Code is, which I don't fully understand, but it's all good. This is not going to build at all, because I need to add it to the make file for one thing. So I call it stage, right? See, we're already kind of getting to the point where this make file is getting a little bit Like there's a lot of repetition. If I knew more batch file programming, which I have not really actively studied since I was about 7 years old and was playing around on my parents' computer, I would take some time to clean this up. But unfortunately, I don't know a lot of batch. I could learn it. Maybe I'll study it a little bit off stream, but oh well. Did that just work? My god. Yeah, okay, draw stage and edit stage I made public, so it worked. And stage map's already public. Cool. So those are probably the big changes I want to make to breakout.asm. Speed this up. This should get amended to the previous commit. Forgot to add it. Do the same thing here. Honestly, I probably want to take much of this collision code, or at least this, like, I don't know, clear collided brick code and move it elsewhere. Like, this is not, it's ball specific, but it also kind of feels like it doesn't belong with the rest of the ball code, but I'm not going to worry about that too much for now. So having done all this, let's fix some bugs. So what I'm going to do is I'm going to do I'm going to now, instead of just having one update it can do, I'm going to allow for it to have multiple updates. So here's how I'm going to do that. I'm going to make an array. And each entry in the array is going to be 4 bytes big. There's going to be this data byte. And right now it's just going to be 8 bytes, just 2, max 2. There's going to be this data byte. There's going to be this. And there's RGBDS supports structures of some kind, although they're not super useful. Because you don't have like proper like indexing on the Game Boy, but R. So I'm going to call this create. And that's going to be RB1, third one, RB1, VRAM update size of. So I'm just following the description here. I'm not going to spend too much time sort of thinking on it or explaining that or understanding it. But I'm defining this structure, even though we're probably not ever going to use these indexes, just so that I can say something like max VRAM updates, just so I can define these like constants, and I can be like, oh well, it's VRAM update that size of times max VRAM updates, like that. So yeah, and then we've got the length here, and I'm going to help. It doesn't really help to align this. I'm not going to bother aligning it. So the point of it's like you should align big arrays, but you only have so many memory locations on the Game Boy that end in a 0, 0. So it doesn't make sense to align every little thing unless it's really performance critical or something. Anyways, so the point of this is that we can have at most 2 VRAM updates. By using this padding and keeping the size of it as a power of 2, it'll make it easier to index. And this way we're going to be able to do multiple VRAM updates. So we do much the same thing. We see if there's any updates to do. And if there are, we go do these updates. I'm going to call this updates instead of update, because we're going to be able to do multiple ones. But on the whole, the behavior is going to be pretty much the same, except there's going to be a loop now. So we first get the VRAM update length. It's redundant. In fact, I'm going to change this a little bit now, because now we have to get it in here, so we might as well. So we return if there aren't any updates to do. If there are some updates to do, we just put that in B. We got a loop. At the end of the loop, we decrement B. If we still have more to do, we continue looping. And then all we do is we're going to point HL at the updates that we have to do. And then as we loop, what do? First thing we do is we get the data. And I'm going to rearrange it actually. It'd be better to have the address first. So we're going to get the address, and we're going to load it into DE. And then we're going to get the data, and we're going to write it into DE. And that's it. So a little bit more complicated than it was previously. But it's going to help us get around this bug where we're not deleting all of the bricks that we should be deleting. And then here it is in ball.asm. What are we going to do? We are going to go to check status, checks clear collided brick. And yeah, okay. So first thing we do is we get VRAM update length. Got to make sure I've exported all of these. I have. Okay, so this is how many updates there are. We're going to increment that, write it back. So now we've added a new update. Then we're going to use we're going to increment into the array by the number of updates that we have. Or, no, this is fine. This is good. This is what we want to do. Sorry. So, Let's say, actually, let's do that instead. Right, so let's say we've just gotten the number of updates so far, and there's 1. Well, that means we want to be 4 bytes into the array to skip past the first one. So we just want to multiply by 4. So we can do that using the shift left instructions. And then we're going to load that into L. Well, we can't load that into L just yet, actually. So we are going to then, we have to add the low byte of the VRAM updates. This is a consequence of it not being 8-bit aligned. We need to add the low part of the address to A, and then load that. We'll load that into L, and then we're going to load H with the high part of the address. Then we're gonna write that in. And then finally, why do I have 3 cursors? Yeah, finally we say we want to set that byte to 1. Oh, but this is a problem. This here is a problem because okay. We have to do what we were doing before. I explained this yesterday, actually. We need to make sure we update the length at the end rather than at the beginning. So, and this is actually good because we have the length appear right after the updates. Or can we? No, we can't do that. Never mind. Ignore me about that. Or in general, just ignore me. So, yeah. So that should do it. We get the length, we get the number of updates we've gotten so far, we've put in there so far. We multiply that by 4 to get the offset into the array. We construct the address for that index. Then we write in the destination, and finally the data that we want to write. Which matches this. There's the destination and then the data. And then there's a padding that we ignore. And we're good. So let's make sure that this works. Where is VRAM update needed? Ah, right. And we're good. Okay, so let's see if I broke anything terribly. So far it seems good. Let's see if we end up in a... Oh, this isn't good. We have a bug here. So this says that we have an update, but the actual memory for the update is apparently empty. What happened here? That's very, very surprising to me. Low. What could cause that? Let's have a look at this. Yeah, I was like a little bit concerned I was like wrapping around somehow, which made my pointer arithmetic. Like going past the page boundary or something, but I didn't. So let's see, what could be going on here? Especially because, geez, reading uninitialized workaround. like that's not the first thing that has been destroyed. So I would think that we have done VRAM updates already. This shouldn't be. I am properly clearing it, right? Clear at every frame. That looks right to me. We write that in. Take that. We write that in. This is really surprising me. And it's C0AE. I mean, that is. Well, that is a lot higher than I would expect, actually. Oh, we're looping. We are looping somehow. We're looping somehow. Oh man, what is going on? This has got to be one of those cases where if we go look at the memory. Yeah, this says we've got 2 VRAM updates going. It's got to be something about that that's... Oh, I know what the problem is. I got it. It's because we're not skipping past the padding. That's the problem. So that's easy to fix. We just... let's start documenting this a little bit better. There we go. Just a little bit better. So that should fix it. Fingers crossed. Reload ROM, run. See if we get any of the same sort of thing. So you can see there were absolutely cases where we were supposed to be deleting 2 blocks on a single frame that we weren't. So we'll see how this goes. And actually, something I'm curious to see is if in doing this, we're going to still see those collision detection errors I was seeing, because there's a question of whether those collision detection errors were the results of actual missed collisions or whether it was because we hadn't updated the screen and it looked like there had been, we were missing a collision. Because so far this seems pretty good. I haven't noticed any issues, which doesn't mean that there aren't any issues. When I talk about like playing it fast and loose with the collision detection, what I'm talking about is right now we only check to see where the middle of the ball is. So it is entirely possible that the middle of the ball might end up going right through some bricks or something like that as it moves, especially if the ball starts moving faster. But so far this seems like it's working okay, so maybe we don't need to touch the collision detection. Arguably, it's not great game design, what we've got here right now, because you want to be generous in the collisions that you accept when they're bad for or good for you, and like you always want to be generous. So if you're making like a shooting game, a shmup, you want to make the player's hitbox as small as possible, and the enemy hitboxes as large as possible. And right now, the hitbox for the ball is not large, even though it's just the center, even though we actually want it to be everything. But you can see that worked. So far I don't see any real need to tweak the collision detection. It seems pretty good to me. So I'm going to save that, and that'll have to be all in one big commit because we changed the interface for the VBlank code. Okay, so that's good. So I guess that does leave us at this point where we want to start thinking about what do we do when you finish the game? Or what do you do when you run out of lives? Both are super important. I think I'm going to implement the lives thing first, just because if you have lives, this will actually be playable. Like you'll knock all the bricks out, and you'll just be like, oh, well, that was underwhelming, but because nothing will happen, but it'll be nice. It'll actually be a playable thing, like a game with an actual challenge if you can run out of lives. So let's allocate some space for that. I don't actually have any in-game code. So let's create a game function. We're going to load it's a good number of lives to have. Let's say 3. 3 lives to start with. And we're going to call that. And then we're going to go look at this ball code. And we're going to say check bottom collision, check bottom collide. Yeah, here we go. So all we have to do is load number of lives. So we're going to decrement that. Now I just need to double check to make sure that this sets flags. Because I think it might be the 16-bit arithmetic. Yeah, the 16-bit ones don't properly set flags, which is super dumb and annoying. But this does set the flag, so okay, so I don't need to do anything else. So what I do is I'm going to put this here. Eventually I'm probably going to refactor this a little bit, but actually, I don't know, whatever. I'm going to have this thing called game over. And all that's going to do for now, all we're going to do there is we are going to we'll call init stage. We're just going to reset the board for now. And we're going to have to we're just going to have to redo everything, right? We're going to init the stage. Okay. I'm going to put init ball and init paddle into here. So that way I'm going to put init stage into here as well. And we're just going to turn the screen off for a second. Draw the stage and then turn the screen back on. So there'll be like a brief flicker. And in the future, we're going to be a little more graceful about it. We'll probably take you to a separate game over screen. But for now, this should all work. So then, oh, sorry. I did this wrong. I'm going to put that in here in the game over. So let's see, does this build? No, because I didn't make this public. So let's give this a try. Reload ROM. I'm going to play breakout. I'm going to trying to do the best I can, but oh no, I missed it. Oh no, I missed it again. Ah, and there we go. And you see now it's actual. There's an actual challenge. This is great. You have 3 lives, and I'm not displaying the lives right now, which is something that I probably want to change. But for now, we now have an actual game. This is a huge moment. So let's save that huge moment. So, okay. We have added lives. I guess the next really obvious thing to do is we want to display that. I haven't really given much thought to this, but I think probably the way to do this is to have like a little status bar at the bottom of the screen, which will show you a ball for each one of your lives. And to do that, I could make it as part of the background, but I think for the sake of sort of showing off as much of the Game Boy hardware as, I don't want to say possible, but, and also maybe for like a little bit of a nice effect, I'm going to use the window. So the window is kind of hard to explain. It is a sort of second background layer on top of the background, but it has no transparency. It's always a rectangle, and only the position of the top left pixel can be controlled. So this is like perfect for status bars, or you can use it for like display message windows in an RPG or something like that by adjusting where the top left is to make it like scroll up and down. You can do it for like a few different things if you're really, really clever, but it's really designed for like a status bar, and that is perfect. And because there's no scrolling, we don't actually need it. We could just draw right on the background and it would probably be fine. Yeah, like I said, in the interest of kind of showing off the Game Boy hardware, let's use the window. So what do we need to do? First, we need to enable the window. Which is going to be by setting bit 5. Bit 5. Let's see, right now, the background tile map is at 9800. So that means we want the window tiles to be at 9C100. Whoops. So we're going to set those, all those. Next, what are we going to do? Next, we need to keep scrolling down here until we find, yes, window position. So we're going to just set this to a fixed number. And it is going to be yeah, so it's going to be at 160 minus 8, so we've got room for exactly one 8x8 tile. So it'll be at 152. Or sorry, no, 144 minus 8, it'll be at 132. Not 132, 136. Math. Embarrassing. And we're going to set that. And we're going to set the window X position to 7 because the register uses -7 for some reason. So Yeah, so a position of WX positions it at the left. So we're going to do that. That's 4B. Cool. So now we've got the window positioned. And just the next thing, well, let's see what happens now. I suspect it's going to... Actually, what's going to happen now is BGB is going to yell at us because we haven't drawn the status bar at all. That's probably what's going to happen. Reload ROM, so it's going to be like, hey, you're accessing uninitialized memory. Nope, it is not. That's good. Maybe I do clear. I forgot to clear it. Whatever. Yeah, so right now, this is completely empty. So just for the heck of it, I'm going to, just as an illustration, in draw stage, I'll put it in draw stage for now. No, I won't. I'll put it up here for now. I'm going to load A with well, for now I'm going to load A with 80. And I'm going to put that at 9C100 while the screen is off. This is just an illustration. I'm going to reload the ROM, and you can see that tile there. And this is the actual background, and then this is the window, and it's appearing over there. So what we're going to want to do is we're going to want to show the ball there. Now, what I could do is I could have multiple copies of the ball tile, but what I'm actually going to do is how the Game Boy's video memory is laid out, and particularly with how I've configured it. This section of tiles, there's 128 tiles here. Those are used for sprites. This section of tiles can be used for both sprites and the background, and then these are just used for the background. So I'm going to actually just move the ball here. Or maybe even here. It's like a nice, good position for it. I don't know. That'll keep me from needing to update the background tiles from interfering. Or maybe I should move that here. Like, lots of options. So for now, I'm not going to do any of that. For now, I'm going to save this commit. Where we enable the window. Oh, and I wonder, one other thing you might see here. Does the sprite appear over top of the window? It does. Okay. Something I probably want to do as well is I want to wait for this interrupt, this line on the screen, and then disable drawing sprites. That way the ball disappears beneath the status bar. But I'm going to worry about that much, much later. Right, so what I wanted to do is I wanted to move where the ball is located. So, in video memory, the ball sprite. So first of all, set up ball OAM. Instead of using a 0, yes, Nelly? That's my cat. I should probably give it a constant, but I can't think of a good constant name for it right now, so I'm just not going to think about it. Ball sprite VRAM index or something. Ball sprite VRAM number. I don't know. So, yes. So, obviously, this isn't going to work alone. What I need to do is I need to move these are no longer going together because we just have the paddle tile data and minus. So we now have to do two separate loops. And it's going to be much the same. I'm going to get rid of sprite data, volatile data. You are going over here, 8FFO. Let's see if that works. I suspect that'll work. So all I did there is I changed this code to, we're going to keep loading the paddle where we had it loaded previously, although this isn't going to work because I'm going to need to update this. Paddle tile is now equals 0 instead of 1. I guess I called these paddle tiles, so I might as well call the one ball tile. Ball.asm. There. That should do it. Fingers crossed. Knock on wood. I did not do it. And that is because I failed to properly update the paddle tile for one thing. No, I did. What happened? Let's look at this. Oh, I'm still putting the ball tile there? Did I not? I guess I didn't update this properly. Boy, did I ever not update this properly. Yeah. Oh, that's what happened. It didn't actually compile. Because I had loop 1 and loop 2, and I forgot to fix that. And also, I'm calling this sprite data here. There we go. Run. Reload run. Run. There we go. So actually, you can see now that the ball is down here. So I'll be able to use this for the window to show you the number of lives you have left. Which was the goal all along. Okay, so having done that, the next thing we're going to need to do is I guess it's the same sort of thing. When we draw the stage, I'm going to have a thing called draw window. Draw window is going to be real straightforward. Yes, Nelly. Hi. Hi. Do you want to come up and help me program? Yeah. You do? Okay. There we go. Hey folks, meet my cat. Yeah. There we go. Cat. Let's take a brief coding pause to pet my cat. I'm enjoying this. I hope you're enjoying this too, stream. Yes. Excellent. Just excellent. Hi, Nelly. Are you a tiny baby? Are you a perfect tiny baby? Yeah. There we go. Okay. So yeah. So what I'm going to do here is number of lives, right? I'm going to define a constant called like starting lives. Come on. Oh, finally. Starting lives. We're going to set that to 3 because that's what I used here. I'm just going to take that, do like a little loop. All I'm going to do is I'm going to get the ball tile. That's what I call it, ball tile. I'm going to get the ball tile. I might need to put this in an included file so I can use it here. I'm going to write that into video memory. And yeah, this will probably work just fine as it is. We're going to return, and I do need to set the actual destination. And we said it was at 9C00 was where we had the. Let me add that as a comment as well. Okay, there we go. So this is what our draw window procedure, and we're going to invoke that both here on game over and also when we're starting the game up. And then the only other thing to do is here in ball.asm, when you lose a life, what do they call it? Number of lives. So we don't need to think about this. I'm going to just immediately leave the procedure instead of continuing doing anything. That should be okay. I think that'll be okay. When we lose a life, I need to actually set up another VRAM transfer. I need to, yeah, much as I did before when I was deleting the bricks, we need to set up a VRAM transfer to delete the ball from the window that indicates your life. So let's see, what's the good way to do this? I'm going to actually go and take a look at the clear collided brick code and kind of steal some of this code. Not all of it, of course, but some of it. So, a very similar thing where we get the number, the VRAM update length. We multiply by 4 to get the offset in here. And it's actually always going to be 0, so maybe this is overkill, because you're never going to be destroying a brick on the same frame as you are dying. So actually, yeah, it's a bit of a hack, but it's like just going to be easier to VRAM update to just hard code this and like spare myself the trouble. So it's destination first. So the destination address is going to be, the first byte of it is always going to be 9C. Because it is just the first row of the window. Oh, sorry, that's the second byte of it. I'll put the least significant byte first. The particular ball that you want to delete is going to be based on the number of lives. If you have 1 life left, it would be the first ball. If you have 2 lives left, it would be the second ball. So is it just the number of lives? 2. So suppose the game starts, you have 3 lives, you lose a life, you want to delete the one here. So that's, yeah, that's going to be 2. So that's all we have to do is we just write that into there. And then we are going to, and then what we want to write is 0. And ball tile unknown. That's what I figured was going to happen. So I'm going to move that to a constant file as well. Ball.inc. I'm going to, and then I'm going to include ball.inc in here for now. There may come a time when I want to, there probably will come a time when I want to move this out of breakout.asm, but for now here it's fine. So let's see if this works. It did not work. Why didn't that work? Oh, because it's not 9C. I'm sorry, it's 9. I mean, that's. No, yeah, we want it to be up here. So 9C100. So that should have done it. We get it, we write it in, and we're done. Let's draw a window. And we do call draw window while the screen is off. And ball tile should be, oh, I don't even need to do that in the loop. I might as well make this a little bit faster. Let's see, what am I doing wrong here? That felt really good to me. You know, I'm actually going to go ahead and I'm going to set an access breakpoint on 9C100. This guy up here. And I'm going to hit reset, and I'm going to see when we write it. We never write it. Clearly I'm doing something terribly wrong. Did I forget to reload the ROM or something? Is that it? Is it as simple as that? Ah, that's totally it. I just forgot to reload the ROM. Ah, I'm a fool. Okay. Yeah, so now you can see we got three balls there because we got 3 lives. And I'm gonna, ooh, look at that. Ah, and there I lose a life. I lose a life. I lose a life, and game over. Great. Whew. And I think that's going to just about do it for me today. I'm ending a little early, as I want to do. Both because I feel like it's a little bit productive, and because I feel like just a little bit out of it today. So, you know, come back another day when I'm going to be better at this. And also because it's just a beautiful day outside today, and I really want to go take a bike ride. So I'm going to save the results there of show number of lives on window. But yeah, I think today was a really exciting day. We now have an actual game in front of us, about 7 hours or so in. Of course, they're probably not the most efficient 7 hours because I've been talking an awful lot and occasionally stopping to get my cat and stuff. But when you that gives you sort of a rough estimate. When you know what you're doing, it takes you about 1 full workday to go from nothing to having a playable game on the Game Boy. And that's why I like this platform so much, or one of the reasons why I like developing on this platform so much, because like, yeah, it's really, really hard, which is kind of fun in its own right, but it is really hard. But on the flip side, like, I don't know, I feel like I could spend a whole week trying to get like Vulkan set up or something like that if I were programming on a modern Windows PC. It's just so complicated. The Game Boy is just so bone simple. It can be really, really rewarding. Anyways, I guess one other thing I want to talk about is like what next. We want some kind of a game over screen. We want some kind of a title screen. We want some kind of like win condition. That's really important. Because I don't want you to just be sitting there. Like if I broke all the bricks, if I actually managed to do it, I'd just be stuck on an empty screen right now. That sucks. So we want some kind of like you win screen, and then from there, you know, the sky's the limit. There's all sorts of different things I've been thinking about, but I think once I add a win screen, I am going to put this code up on GitHub, and I'm going to put the ROM up for download as like a alpha release or something like that, so that people can try it out. And then from there, we're gonna start making things fancier and really adding a lot of polish and features and stuff to it. Power-ups, enemies maybe, just various things. So exciting times. Thank you for joining me. As always, this video is up on YouTube, going to be up on YouTube along with all the videos of days past. If you want to catch up and see how we got to this point, the link is in my whole About Me section below. Otherwise, yeah, have a really great weekend, and I will see you on Monday. Thanks very much for joining me. Take it easy. Bye.